Namaste Vidya, खुश रहिए. I JVN Muskan Kumari from the Department of Science and Technology, and I am working here as an assistant professor in JVWU Women's University and Faculty of Education and Methodology. So today I will discuss the basic topics regarding your session, like clustering algorithm. And just before this session I have discussed with you the overview of the clustering, isn't it? So I'm just going to conclude once again regarding the clustering, overview of clustering and their types, isn't it? And then I will just come to the point of your clustering algorithm, isn't so clear? So here, this one session, you are seeing here that clustering algorithm, isn't it? So just discussing this before, I will just tell you some basic points regarding the clustering once again. So clustering is basically, you know, that you are just dividing and subgroup a bunch or a huge amount of data into the multiple subgroups, and that is subgroup is known as the clustering, because the in a group the all the elements and data sets whatever in that one has same type of the property, isn't it? So how clustering workflow, clustering's working is how done, completed, isn't it? So to complete the clusters your data, firstly you prepare the data. Second, create similarity matrix between them, yeah, properties between them. Run clustering algorithm, then apply, you are applying the some clustering algorithm and interpret the results and adjust your clustering, isn't it? So preparing the data, create similarity matrix, run the clustering algorithm, and after that interpret results and adjust them. Okay, so now if you talk about the prepared data, so what will you, as with any machine learning problem, you must normalize, scale, transform the features data, isn't it? While clustering, however, you must additionally ensure that prepared data sets lets you accurately calculate the similarity examples and the isn't prepared. Now, if you talk about what is the prepared data set, whatever the data set or sources from where you are getting all the data, so you are just using that data and normalize that once. Also, you can scale the data and transform the features of that data also. Isn't it? So this is basically the preparing of the data. Now, if we talk about the create similarity matrix, then what? Before clustering algorithm, applying the clustering algorithm, we are just going to make a group of the data, and it needs to know how similar pair of examples are, isn't it? We can also quantify that similarity between examples by creating a similarity matrix. Okay, so creating the similarity matrix requires you to carefully understand what your data and how to derive similarity from these features or your features, clear? So a third point is will be the run some clustering algorithm over that one's data. A clustering algorithm use the similarity matrix to cluster data, isn't it? And basically we are focusing on the key means property or algorithm on for clustering. Now last one, results is going to be interpreted and adjust to you according to you. Checking the quality of your clustering output is iterative and exploratory, because clustering lacks truth, and that can verify the output also. There is one predicted output and one is predefined, and one is resultant. You are just match your resultant output with the predicted output, isn't it? If the that get completely matched, then this is right. Or if there is some differences between these two outputs, then you just transform that outputs according to the predicted output. So you verify the results against the expectation at the cluster level and example. Also, improving the results require the iteratively experimenting with the previous steps to see how they affects the clustering. Okay, so this is all of the in regarding your that ones. So now, coming to the clustering algorithm. Okay, so there are various methods of the clustering, like what partitioning method, hierarchical methods, density methods, model based methods. Okay, so what all methods do? Firstly, partitioning method. Partitioning methods involves the partitioning of the data and clustering the similar group of data items into one. Okay, so this is basically doing and this process is basically doing that is known as the partitioning method. Okay, common algorithm used in this method are what? Key means algorithm, key Medoi's algorithm, and key modes. Okay, key mean, key modes, key Medoids. Now come to the next hierarchical method. Hierarchical method is what? Hierarchical method involves the decomposing the data hierarchically, isn't it? They are decomposing the data hierarchically. Two types of hierarchical method exist. First is agglomerative, bottom-up approach, that is known as, and divisive, that is top-down approaches. Okay, now come to the density-based method. So what? Density-based method are used in anomaly detection. Anomaly detection, the data points that are highly dense, the data points which are highly dense group together, leaving the data points and with the low density. So you can use here the some applications like the DV scan. DV scan is density based spatial clustering of application with noise. Okay, and optics. Optics is basically ordering points to identify cluster structure. Okay, now if you talk about the model based methods algorithm, so model based method involves applying a model to find the best clustering structure like EM. EM is expectation maximization algorithm we will use here. So there are various types of the methods which are used for clustering. Okay, so these all are the, and in this all methods there are multiple algorithms are used for the implementation. Now types of the algorithm. Since the task of clustering is subjective, the means that can be used to achieve these goals and plenty also. Even methodology follows a different set of rules for defining the similarity among the data set and data points, isn't it? There are more than 100 clustering algorithms known. Now, if we talk about the connectivity models, as the name suggests, these models are based on the notion that the data points closer in data space exhibit more similarity to each other than the data points like the further away. Connectivity models is used here, and whatever in the second approaches, if you talk about that the data points that classified as a single cluster and then partitions is as a distance increases, isn't it? However the distance is increases, you are partitioning that data also. And the choice of data distance function is subjective. These models are very easy to interpret but lack scalability for handling big data sets. Example of these models are hierarchical clustering algorithm and its failure. Now, if we talk about the centroid models, then what is this? These are the iterative clustering algorithm in which the notions of similarity is derived by the closeness of a data point to the centroid of the clustering. And K means clustering algorithm is a popular algorithm that falls into this category. In this model, the number of clusters also required at the end have to mention the beforehand. Okay, now if you talk about the distribution models, so this is also similar as these two models, in which clustering models based on the notion of how probable is it that data points in the cluster belongs to the same distribution, and these models often suffer from overfitting. And a popular example of this model is expectation maximization algorithm which use the multivariant normal distributions also. Now, if you talk about the density models, then we can say that these models search the data space for area of varied density of data points in the data space, and it isolates various different density regions and assign the data within these regions in the same cluster. So popular example of density models are DBS scan and optics. Okay, so I hope that this session uh, you have enjoyed, and if you have any problems in this session, then please write your query into the comment section box, and also let me know that what's your query regarding this session, and I will try to resolve that all of your query regarding this session and the previous session in the next session whenever I will connect it with you, isn't it? So please read these sessions from different standard books and websites, open source websites, which I have already discussed with you. But I just want to tell you some questions which might be arises from this session. That will be the types of the clustering algorithm. Explain the connectivity models with an example. Why density methods is important? What is the importance of this one? Isn't it? What functions provided by this partitioning of the method, what is the importance of this one, isn't it? This type of questions may be arises, so please be prepared of these all type of questions, read these sessions carefully. Once again, if you don't get this all the points. Okay, thank you.